So Fortune's questions on the screen, I'm going to read. And as I read, folks, we're going to translate the information into symbols on our diagram. Okay, remember that's the first thing you do. Whether you do analytical geometry or whether you do Euclidean geometry, you spend your time with the information that they gave you and put it on your diagram. Let's start. In the diagram, the circle with center, now they tell us that T over here is the center of the circle. It cuts the y-axis at P. Now remember, they said it cuts at P, so the x value is 0. So this is going to be 0, and whatever the y value is going to become. And the same here for R. It cuts the y-axis at P and R, they said. So this is 0 and something. Now, almost the same as the previous question. The previous question, instead of giving you that top coordinate as an intercept, we gave you a tangent. Okay, so again, they're going to ask us for those coordinates. And folks, look at this. The coordinates are related around this point over here. Okay, so from there to there, there's the radius that we need to find. The 5 only runs in this little section over here because this is where 0 starts. So we need this little bit to find the whole radius. Don't be caught with things that are actually elementary, that are meant to be easy for you. Okay, so let's read on. The line through P, there's a line going through P, lovely, and S, which is the coordinate pair -3 and 8, they say, intersects the circle over here at N and the x-axis down here at M. So we have the x-axis, so we know that this is 0 and something. There's quite a few coordinate pairs where you see that there's one part of it is missing. Now they tell you the information that's most probably going to seal the deal for us. Look at this. They say the line NS, this part here, is equal to the line segment SP, and MT is drawn, almost like the previous one. Let's stand still at the last information. Your very first theorem that you learned in grade 11, that if you have a line, listen to the language, the conditions are you must have a line that passes through the center of the circle and goes to the midpoint of a chord in the circle. That's the two conditions. What is the conclusion? The conclusion is that line is perpendicular to the line that's bisected. Your very, very first grade 11 theorem. So the first thing we're going to do here is we're going to indicate that this is a right angle. Again, look at the relationship. A line that passes through the center of the circle, there it is, TS, and it goes to the center of a chord is perpendicular to that chord. Okay, first theorem done. Now they ask us, you need to give a reason why is TS perpendicular to NP. So 4.1, we discussed it just now. Why is TS perpendicular to NP? Well, you can say TS passes through the center of the circle and the center of the chord. Therefore, ST is perpendicular to NP, and that is basically your reason. A line that passes through the center of the circle to the center of the chord does so perpendicularly. It's for 1 mark. Okay, 4.2. Determine the equation of the line that passes through N and P in the form mx plus c. Okay, so N, let's see, where's N? Where's our N? Our N is over here. The line passing through N and P. We need the equation of that line in the form y equals mx plus c. So let's find the gradient here. Remember, what do I have? I have a point that lies on the line, that coordinate pair. I either need another point, which I don't have. Okay, so I've got a point I don't have another point, so I'm looking for the gradient. And the gradient I can find by using the very first theorem. Okay, so let's find the gradient of ST. Now, folks, please write down your subscripts for the line so whoever marks your work knows where you are. 5 minus 8 is minus 3. 0 minus minus 3 is plus 3. So that gradient is minus 1. Now remember, that goes straight. That gradient there is negative 1. Now what do we know? We know the radius is perpendicular to the tangent at the point of tangency. So now we have the gradient of PM. Let's continue. Therefore, the gradient of PM is indeed 1. And now the equation, now look at how I'm going to indicate it. The equation of PM is y minus 8 over x minus minus 3, which becomes x plus 3, and the gradient for that line is 1. Well, that's simple enough. All we need to do now, Fortune, is cross multiply and get it into the form that they wanted. We've identified the gradient correctly. Let's just clean it up. So therefore, y minus 8 is equal to x plus 3. That goes over, so y will equal to x plus 11 will be my equation for PM. Okay, that is number 2. Now, that was for 5 marks. It's quite a nice set of marks. You will get a mark for the first gradient, a mark for the perpendicular relationship, a mark for the correct rule, and then 2 marks for your answer at 4.2. Okay, so let's go and look at 4.3. Determine the equations of the tangents to the circle that are parallel to the x-axis. Now again, they're giving us stuff that's parallel to an axis. If a line is parallel to the x-axis, it's a horizontal line. This is the same question than the previous one. It just doesn't work with another tangent. Okay, so let's have a look. How are we going to get out of the trouble here? So for 4.3. For 4.3, I need to look at, let's see, I've got a little right-angled triangle over here that I can work with. As long as I need that y value, because I need to know how far this point is from the center. So if this was 7, then this will go to 5 minus 7, which is minus 2. Okay, so I need the y coordinate of point P. Okay, I'm just going to put a small q in there for now. And let's see. This distance here is the length between those two. This distance we can find for ST, and then that distance. So all our distances is going to be expressed in terms of Q. So I'm going to try and keep that on the screen. We're going to work with that length first. Q minus 8 all squared plus 0 minus 3 is minus 3 all squared. Okay, so that's squared plus this squared. I'm using Pythagoras. There's a right angle. I'm using Pythagoras. Why am I doing it? In the Pythagoras, if I use Pythagoras here, I can see that my distances are going to be, they're perpendicular here, and my only variable that I'm left with is the Q. For a moment, I had a little bit of a brain absence there. So 0, this distance here is 0 minus 3, so it's plus minus 3 squared. That distance is 5 minus 8, which is plus another minus 3 squared. So this is the one line, that line, plus this line here, all squared, has got to equal that distance there. 0 minus 0 is nothing. Q minus 5 is what's left. Okay, and what am I applying here? I'm applying Pythagoras' rule. Okay, because I'm in a right-angled triangle. Okay, now I'm lucky here because the one Q is on the left side, the other Q is on the right side. So the Q squareds are going to cancel. Let's have a look at how this proceeds. I now am going to multiply this out because those two brackets here, this one and that one's not the same. So I get q squared minus 16q plus 64. This is 9 plus 9 plus 9 is plus 27, gives me q squared minus 10q plus 25. Now, folks, look at this. This is what I said. The q squareds say goodbye. I can move now everything with a q to the left, and everything that's not connected to q, the constants, I'm going to move to the right. Then I find the value of the q, which is the y value of point P. Let's do that. Okay, so if this comes over, it becomes positive. So it leaves me with minus 6q. Now, folks, if you add all of this together, in other words, you add those two, you throw it over, and you add the 25. When that goes over, it becomes negative. You can do that on your calculator. It gives you minus 66. So now we're in a position where we can find q. Minus 6 divided into minus 66 leaves us with q as 11. Okay, now remember, that wasn't the question. The question was the equations of those tangents. So let's just go back to the top. I now have this y value there, and that y value is 11. Now look at this. That means that this length here, that length there, 11 minus 5 is 6. Okay? So the tangent here will be the tangent there is the tangent y is equal to 11. The tangent down here, which is parallel, oops, I missed that point. Let me just see if I can move that whole line up. There we go. That's our tangent there. Now then we go 6 units down from 5, and this tangent will have equation y is equal to negative 1. Now that was for how many marks did we say? Determine the equation of the tangents for 4 marks. To get 2 marks per tangent, you first of all need to find that coordinate pair. There might have been a different way to do it. This is analytical geometry, folks. You can do an analytical geometry, and in trigonometry, you can pretty much do in so many different ways and get to the correct answer. Okay, so let's just answer that question. The tangents then, the tangents, we said, is y is equal to 11 and y is equal to minus 1. Now at the same point, we then found the coordinates of r to be 0 and negative 1. So let us put it on the diagram for ourselves to remind us that we have it. Okay, the next question for 4 marks. The length of MT. Okay, so what do I need now? I need the x value for the point M, so that if I want to find that length there, I can use Pythagoras. This is 5 units long from there to there. Okay, if I have this x value here, I've got that length, and with Pythagoras again I can find MT. There's a right angled triangle. Okay, so what happens at M? Well, the line MP crosses the x-axis. So at that point, y is 0. So let's go back to the MP equation. It was over here, remember? Y equals x plus 11. So for the coordinates of M, we first have to make y equal to 0. Where do we do it? We do it at y equals x plus 11. And folks, you see, if y becomes 0 there, we can see that x will be negative 11. So I'm going to draw that little triangle here. We've got this happening. We've got the right angle. We have that distance. We have this distance. And we can now find that distance there with Pythagoras. Okay, so MT is equal to the square root of 121 plus 5 squared is 25, and that gives us the square root of 146 as an answer. And that was also for 4 marks. That was a little bit less work than the previous one. Looked a little bit less intimidating, Fortune, so I hope that made sense to you. Okay, the last part for 5 marks. Now this is the question, or the second question with subsection with 5 marks. Number 2, remember I said to you here, was also for 5 marks. So they're asking us in the last question, let me just make space for us here to do 4.5 in. 4.5, and again, I'm way too much to the one side here. There we go. 4.5 is as follows. Another circle is drawn, and this is the question that happens. So I'm not going to do this one. We're going to talk through it. They say it's like the previous one. They now say there's a right-angled triangle that we work with. We now want the equation of the circle that circumscribes those 3 points. Now let's have a look. Here's our triangle. This is our triangle over here. Precisely what we had in Lazarus's question. A triangle, right-angled triangle that appears in the middle of nowhere. So what do we need? We need to find the midpoint of MT. Remember, this is now minus 11. Of MT to find the center of that circle. We've just calculated, like in the previous question, we've just calculated the length of MP. What do you have to remember? That to find the radius, it is a half times the length of MT is the radius of the circle. So you find that point with the midpoint formula. That's the center of the circle. You find the radius you've already found in the previous question. You just have to halve that. And then remember that from that M value, that's the center. So it's x minus the x value there, y minus the y value of those both squared is equal to the radius, which is a half MT, the whole thing squared. So it becomes a quarter of MT, or 1/4 times the length of MT squared will give you the radius.